Hi, my name is Radu Kish and I am the head of technology at MultiversX. I will present a short introduction to blockchains based on the MultiversX ecosystem. We are going to start at a very basic blockchain knowledge, learning about what blockchains are, then touching on cryptocurrencies, consensus models, and understanding the improvements the MultiversX blockchain is adding. So let's dive right in. Blockchain, beyond the buzzword and the hype, is just a database. Actually, it is a distributed database that is maintained by a large number of computers and is continuously growing with every new record added. It is not that sophisticated. You could keep the records of a blockchain in a spreadsheet. Because the database is replicated across a network of computers, it is also called distributed ledger technology. A characteristic of blockchains is decentralization, because there is no single central organization that makes decisions, runs, and controls the blockchain. In contrast to traditional banks, a blockchain is run by thousands of computers that run a software containing a protocol, the set of rules for processing and ordering the database records. Almost anyone could run this validation software on a computer called a node, making it resistant to censorship and single point of failure. The entries or the records of the database are called blocks and are linked together by a sort of digital fingerprint, a cryptographic hash, that uniquely identifies them. Each new block must contain a reference to the unique identifier of the last block, and this way a chain of blocks is created, a blockchain. The blockchain's operations are: blocks can only be added. No update or delete operations are allowed on the blockchain for finalized blocks. Blocks that cannot change. This makes the blockchain immutable. The next block contains the digital fingerprint of the previous one. If a block is changed or deleted, this would also change every following block, making the blocks invalid. The blockchain provides improvements in various fields. The improvements are transparency. All blocks and transactions are visible to anyone who has access to the blockchain. Transparency can be crucial for applications that require trust among the participants. Security. Blocks and transactions are verified by nodes in the network through cryptography and consensus algorithms before they are added to the blockchain. Automation. Smart contracts are programmable contracts that automatically execute actions once predefined conditions are met. Efficiency. No need for the middleman. Transaction times are reduced to seconds or minutes compared to traditional processes. The traceability. Because of the transparency of blockchains, tracking the movement of tokens and data, for example in supply chains, on the blockchain is also possible. Blockchains could be used in banking and finance for payments, trade finance, insurance, audits. In business, like supply chain management, real estate, art and collectibles, healthcare, media, energy, government, voting, taxes, identity management, but also in gaming, big data, and cybersecurity. Most important consensus algorithms are based on proof of work. This is the original consensus algorithm in Bitcoin, where a miner competes to solve a mathematical puzzle, and then the first one to solve it gets to add a new block. And proof of stake based, the probability to be selected as the proposer of the new block is based on the number of coins they are staking as collateral. Proof of stake is more energy efficient compared to proof of work, but aims for the same level of security. Incentive models play a crucial role in the success of the blockchain network. The validator nodes, responsible for verifying and processing both blocks and transactions, have to be incentivized to maintain the security, integrity, and performance of the network. Incentives could come from mining rewards, staking rewards, where the validators earn new coins as reward for validating transactions and proposing new blocks, from the transaction fees, where users pay a fee for their transactions processing, governance tokens. Some blockchains or decentralized organizations offer governance tokens as incentives. They can be used for decision-making, for network upgrades, or for staking. Penalties and slashing. if the positive enforcement does not work in proof-of-stake blockchains, malicious validators can have their staked coins slashed as a penalty. This acts as a deterrent of malicious behavior. Trust is a prerequisite in any meaningful interaction in traditional systems, may it be with government, banks, institutions, or individuals, and is based on reputation and previous experiences. Satoshi Nakamoto mentions in his 2008 paper titled Bitcoin, a peer-to-peer electronic cash system, that an electronic payment system based on cryptographic proof instead of trust is needed. Decentralized blockchains strive to reduce the level of trust between the participants and replace the trusted intermediaries with mathematics, cryptography, and economic incentives. This way, the human or institutional intermediaries are replaced with mathematical algorithms, consensus mechanisms, transparency, and auditability. A cryptocurrency is a digital, cryptographically secured and decentralized medium of exchange that exists mostly on blockchains. Unlike traditional currencies issued by governments, fiat currencies, cryptocurrencies are generally not issued by a central authority. Cryptocurrencies represent a revolutionary shift in the world of finance, providing a decentralized option for value storage and transfer, among other uses. Wallets are a digital tool that allow users to manage, secure, and use cryptocurrencies such as Bitcoin or EGLD and other digital assets based on a blockchain, like fungible tokens or non-fungible tokens. The blockchain wallets do not physically store the cryptocurrency, like traditional wallets, but manages the cryptographic keys, a public key used for receiving funds, and a private key only known by the owner, used to access the funds and sign transactions. There are different types of wallets, like the software wallets, desktop, mobile, web. These are connected to the internet and are considered less secure. Hardware wallets, like Ledger, Trezor, these are not connected to the internet and are considered more secure. There are even paper wallets where the physical documents, where the private key is saved, but this could be lost or damaged. Custodial wallets are wallets where the private key is stored by a third party, like a cryptocurrency exchange. Non-custodial wallets are wallets where the private key is stored by the owner and has full access over their funds. There are some risks associated with the wallets, like the loss of the private key, which will incur the loss of the funds, and phishing. If you send your private key to or password to a scammer, you could get your wallet drained. Cryptography is the base layer for security in a blockchain. The cryptographic techniques used are hash functions for data integrity and block linking, digital signatures confirm that a particular entity has created a transaction or a block, public key cryptography used in the wallets to secure access to funds and ends anonymity, because you need just the public key, not a link to a physical identity, multi-signature wallets, where multiple private keys participate in generating a signature. Zero-knowledge proofs could be used for privacy. This is a method with which a prover can prove to a verifier that something is true without revealing any additional information. Blockchain interoperability refers to the ability of different blockchain protocols to communicate and conduct transactions with each other. This interoperability is important because there are diverse ecosystems. As the blockchain ecosystem continues to diversify and expand, interoperability between systems becomes more important. Maximized efficiency. Assets transferred should work across different blockchains without the need for third parties. And the network effects. Different blockchains that are interconnected could benefit from the interoperability. Interoperability is achieved through cross-chain platforms like Cosmos, Polkadot, that have developed protocols for communication between different blockchains. Side chains, secondary chains that operate independently and transfer assets to a main chain. Blockchain bridges, general in general, these are smart contracts that allow token transfers between different chains. Wrapped tokens, these are assets from one blockchain represented as tokens on another blockchain, like WBTC on Ethereum. Oracles, which are third-party apps that push external data to smart contracts. The MultiversX architecture was designed to offer a high-throughput public blockchain aimed at providing security, efficiency, scalability, and interoperability beyond the current state-of-the-art. High throughput, 30,000 transactions per second, can be processed on the 3 shards. Security, the state-of-the-art cryptography and consensus mechanisms are used. Efficiency, secure proof-of-stake consensus is much more energy efficient than the proof-of-work, aiming for the same level of security. Scalability, the adaptive state sharding, will allow, in case of an increased usage, that the number of shards can be increased to be able to almost linearly scale the number of transactions processed. Interoperability, an SDK for sovereign chain creation, is being developed. Bridges to major blockchains like Ethereum and Binance Smart Chain exist, and these allow the transfer of wrapped tokens like wrapped BTC and wrapped Ethereum. MultiversX consensus mechanism is called Secure Proof of Stake. It's an improved version of the Proof of Stake designed to offer enhanced security and energy efficiency. Secure Proof of Stake employs a random selection process for the validators, making it difficult for malicious actors to predict and attack the network. This mechanism enhances the platform's security while also maintaining a high throughput and low latency. Let's look in more detail how the SPOS works, simplifying the process as much as possible. Based on the previous block randomness source, the consensus group selection is going to be selected. The first validator that is selected is also the proposer. The other members of the consensus group are the validators. The proposer creates a new block that has the linking to the previous block, the block with a nonce tree, as the block 3 hash. There are other meta information in block 4, like the new randomness source for the next consensus group selection and the signature, which is not yet created. We also have mini blocks from a sender shard, K, for example, to the receiver shards from 0 to N. These mini blocks contain the transactions that originate and are going to go to the same shards. The proposer is going to send the blocks to the validators. These validators are going to verify the blocks, processing the transactions, and if everything is okay, they are going to send their signatures back to the proposer. The proposer aggregates the signatures and then broadcasts the block to the entire shard. And after this, the block and the signature are sent to the meta chain. The meta chain is going to be able to add the transactions from shard K in the notarized blocks only in block 5. After this, the meta chain block, including the blocks and the mini blocks from shard K, are going to be sent to shard J, where they could be added in the block 6, as soon as in the block 6. Okay. So, sharding, let's go back to sharding, which is a scalability technique where the network is divided into smaller partitions called shards. MultiversX proposed a new type of sharding known as adaptive state sharding, which combines network, transactions, and state sharding. This results in improved performance, greater scalability, and more efficient use of resources. The adaptive nature means that the network can reorganize shards dynamically, ensuring optimal performance. So let's look at the simplified example where the number of shards has to increase from 2 to 3 and see how the nodes and the wallet addresses are mapped to the shards. So the first step would be the splitting of shard 0 in shard 0 and 2. So half of the nodes that were on shard 0 are going to go to shard 2, half are going to go to shard 0. This is because we have in the node pool new nodes that have to synchronize their state, and this way they can have other nodes provide them the state needed to start processing blocks and transactions. So we assigned the nodes from the node pool to shard 0 and shard 2. And now we have 3 shards, shard 0, shard 1, and shard 2. Now we have to see which addresses are going to be mapped to which shards. This means what nodes or the nodes from which shard are going to process which transactions from what addresses. So let's look if we have 3-bit addresses like 000. Let's see how this address is going to be mapped to the different shards. We look from right to left, from the last bit to the first bit, and assign the addresses to shards. So looking at address 000, we see that the last bit is a 0, and then we have to go on the left side here. And because here we have still 2 shards, we have to decide on the second to last bit in the address. So this is going to go again on the left side to shard 0. So this address, the address 000, is going to be processed by shard 0. Looking at 001, we see that the last bit is a 1, so we are going to go to the right, to shard 1. We are going to go 010, so the last bit is a 0, we go to the left side, second the last bit is a 1, then we are going to go to shard 2. And this is how all the addresses are going to be mapped to shards. We can see that shard 1 is going to have twice the number of addresses that is going to be processing compared to shard 0 and shard 2. Let's look at the transaction where the sender, for example, is 010. So first we need to compute the sender shard. The sender shard is shard 2. After which we have to send this transaction to the shard 2, and it's going to be processed here in the next block. We look at the receiver. If the receiver is 111, the last 1 bit of the address is a 1, so the receiver shard that has to process this transaction is shard 1. It's going to be able to process this transaction only in the next block, so in the 4th block in this case. Okay, after the transaction is processed also in the destination shard, the transaction is finalized. MultiversX uses its WebAssembly virtual machine, WASM VM, for executing smart contracts. It allows developers to write smart contracts in multiple programming languages, making the platform more accessible. The most used programming languages are Rust and C++, but also other languages could be compiled to WASM, like Python, Go, Java, PHP. WebAssembly ensures high performance and quick execution of the smart contracts. This is a graphic depicting the MultiversX VM. The node communicates to the VM through VM inputs and VM outputs. The MultiversX VM contains the contexts for working with big integers, metering, runtime, output, storage, async. And it also has execution environment interface methods, which the WASMer, the actual VM that is going to run the executable contracts, can call in order to get information about the accounts and so on. The native token of the network is EGLD, used for transaction fees, staking, and rewarding validators. MultiversX has introduced e-standard digital tokens, ESTP, which allow for the easy creation of custom tokens on the network. One important implication is that a token issued on our network does not need a dedicated smart contract. token transactions do not require the virtual machine at all. The ESTP standard is used to manage fungible, semi-fungible, and non-fungible tokens at protocol level. The MultiversX protocol introduces native NFT support by adding metadata and attributes on top of the already existing fungible tokens. Now, I'm going to do a live demo to use the wallet to sign a transaction, view this transaction on the Explorer, and get some transaction information from our API. So, our wallet can be found on wallet.multiversx.com. I already have a wallet, and these are different methods you can connect to your wallet. I'm going to use the Exporter app, but you could also use a hardware ledger device or a browser wallet. Other options are the key store or the PEM file, but these are not recommended because if you upload your key store and your password or your PEM file to a fake address, you are going to get your funds lost. So I'm going to start the Exporter app, and I'm going to sign in with my Exporter app. So this is my wallet. We can see the transactions I made before. We can look at my tokens. So from the dashboard, I can see that I have the native token in GLD, and I also have some MEX tokens here. I don't have any NFTs, but I could stake my tokens in order to get rewards. I could validate to create a node that is going to run on the network, the protocol, and validate and process the transactions. I can create NFTs, I can create tokens, and as a security feature, we also have the guardians, where you can add another wallet, like a 2FA authentication method. Okay, so let's go and do swap transactions, for example. I can go on our X exchange. Let's log in again. I can log in also here with my wallet. I can connect to X exchange with a wallet, and I'm going to log in inside the app. Okay, so if I go here, I can swap one EGLD for MEX. I'm going to press swap. So I want to swap one EGLD for at least 6,035,000 MEX. I got a signed transaction on my Exporter app. This is where my private key resides. And only from here, I can sign the transaction. The private key is not leaving my device. So I signed the transaction. Actually, there are two transactions, one from going from the native token to the wrapped EGLD in order to be able to process ESDT transactions, not native and ESDT. So if we look on the Explorer, what happened here, we can see that my transaction is pending. So this is my address from Shard 2, and it's going to a contract in Shard 1, the MEX wrapped eGold liquidity pool. So it's pending. It's a smart contract execution. It was included in the mini block 765, which goes from Shard 2 to Shard 1 and has just one transaction, my swap tokens transaction. On Shard 2, it was processed 55 seconds ago at first, and on the receiver block, it was processed 37 seconds ago. We can see here the block hash on the shard 1, where it started, how many transactions were in this block, who the proposer was, and also the other 63 consensus group members that verified the proposer's block, and they got to the same result. They validated the block and sent their signatures. We can see here there are a lot of ones. In our public key bitmap, 1 means that the consensus group member from that position has sent their signature. We can see the mini blocks that are from one shard to another shard, and they are grouped. They are grouping the transactions that go from one shard to another one. And we can also see the previous hash. So this block 050 is linked to the previous block 0.49 by the block hash FAD. So our block is linked to the previous block through the hash. So let's go back to our transaction. We can see that our swap transaction has the hash starting with 695. And we also can look for more information on the API. The API provides a set of methods that you can get information about the accounts, about the blocks, about mini blocks, about rounds, and about the transactions. If you have a transaction hash, you can put the transaction hash here and just get the information. So this is our transaction. So we did a swap from shard 2, where my account is residing, to the receiver shard 1, where the contract, the max wrapped eagle liquidity pool is residing. You get much more information here than just what in that transaction was. You can parse this information in order to be able to process different other stuff. So let's go again on the Explorer and look for this transaction. So it was processed with success 3 minutes and almost 30 seconds ago. And we can see it was from my account on shard 2 to the max wrapped eagle liquidity pool. There is an input data on the transaction. If we look at the smart, we can see that I transferred wrapped eagle 1. It is denominated with 18 zeros. I called the method swap tokens fixed input from the contract, and I want to receive max at least 6,035,000 max. The processing generates some smart contract results. If the smart contract has to process further and communicate to other smart contracts, this processing is going to be reflected in the smart contracts results. So the liquidity pool did a swap tokens for me from wrapped eagle to legs. Some of the fee that I paid goes to the fees collector, and I am getting back my max back, and I got more than I minimally would have accepted, 6,096,000 max. So this is how a transaction is processed on our blockchain, a cross-shard transaction. Let's look a little bit on the blocks. So we can see the 3 shards and the meta chain here, and how many transactions there are. If we press on a block, we can see that there is a proposer, there is the previous block hash, we have the mini blocks, 1, 2, 3 mini blocks. One is from shard 0 to shard 2, from shard 1 to shard 2. One is from shard 2 to shard 2, and one is from shard 2 to shard 0. We can also see on the dashboard that we have the epoch 1147, and we still have 4,700 rounds left. Every 6 seconds, a round passes, and a maximum of 1 block can be proposed in that 6 seconds. We also have the validator nodes that are running the transaction and block processing and verifications. Right now, we have 3,200 nodes. We have 3 processing shards and the meta chain that notarizes the blocks from the different shards. We also have 40 nodes on the queue that are waiting for some of the 800 nodes per shard to exit in order to be able to enter the 3,200 validators that are actually earning the rewards by processing the transactions and securing the network. In the future, we are going to have an auction here so that the top 3,200 nodes, according to their state, are going to be generating rewards. We can go here to look at what nodes are on shard 0. We can see that they have the rating 100. In our secure proof of stake consensus mechanism, your chance of being selected proposer is based also on the rating. If you have the rating 100, you have the highest chances to be selected as a proposer and earn rewards. Also, the consensus group members, the other validators, 63 on shards and 400 on the meta chain, are also earning rewards. Okay, this was the short introduction to blockchains. I see you next time.
Thank you.